Okay, everyone, welcome back to our Calculus 3 class notes. We're on the last page of the section 15.7 notes, and we are looking now at example 93. So remember, we're working with triple integrals in cylindrical or spherical coordinates. So we want to evaluate x squared plus y squared dv over domain D, where D is the solid defined in example 92. So in this example, we looked at it right here. Okay, so remember, this is the cone. Phi equals pi over 3, and then we're cut from the solid sphere row is less than or equal to 1, so that would go all the way around, but we cut the ice cream cone out of that sphere with this cone. Okay, now I want to integrate x squared plus y squared. I just don't want the volume like I did here. So in this case, I want to integrate x squared plus y squared. So since spherical coordinates is the easiest coordinate system to use for such a domain, I need to figure out what x squared plus y squared is in terms of spherical coordinates. So we know x is rho sine phi cosine theta, square that. Y is rho sine phi sine theta, square that. Notice that I have a rho squared sine squared in each term, so I can factor that out, and then I get cosine squared plus sine squared is 1. So I just simplify this to rho squared times sine squared phi. So then I'm integrating over the same domain D, rho squared sine squared phi, dA, I'm sorry, dV, but dV is also rho squared sine phi, d rho, d phi, d theta. So now I have to bring these like terms together, get rho to the 4th sine cubed of phi. So first integrate with respect to rho, get rho to the 5th over 5 from 0 to 1, apply the fundamental theorem of calculus. That just becomes 1/5, factor out the 1/5. Then I integrate sine cubed. Now the way to integrate sine cubed is to factor off a sine. Factor off a sine, and then sine squared becomes 1 minus cosine squared, and I can let u equal cosine phi. Becomes a simple u substitution, so minus du is sine phi d phi. Bring out a negative sign, so I have negative 1/5. Integral of 1 minus u squared du. Okay, now I changed instead of changing the limits to u, I write it as phi equals 0 to phi equals pi over 3, as I've done most of the time. And then I say, okay, integrate with respect to u minus u cubed over 3. Again, as phi goes from 0 to phi equals pi over 3. So now I put everything back in terms of phi. It's cosine phi minus cosine cubed phi over 3. So plugging in the limits using the fundamental theorem, cosine of pi over 3 is a half. So a half cubed is 1/8 times a third is 1/24. Minus cosine of 0 is 1. Minus cosine of 0 is 1, so 1/3. Simplify this, becomes negative 5/24. Factor the negative 5/24 out, I get 1/24. And then I integrate d theta from 0 to 2 pi. I get theta, I get 2 pi, so 2 pi over 24, or pi over 12. And that's the end of section 15.7.